Further Maths AS Unit 3 Prerequisites for Momentum and Impulse. You need to know the suvat equations. These are the equations of uniform acceleration, and they are based on S, which is displacement, U, which is the initial velocity, V, the final velocity, A, acceleration, and T, time. And the reason S is in red is to note that in physics X is used instead of S, so in physics they're the suvat equations. So here they are. V equals U plus AT, so the final velocity is the initial velocity plus the acceleration times time, so that's the change of velocity due to the acceleration. S equals Vt minus a half AT squared. You should look at the derivation of these in your ordinary maths A level, so we're not going to dwell on them here. S equals Ut plus a half AT squared. S equals U plus V times T over 2, or if you think of it as U plus V over 2, that is the average velocity times the time, and then we have V squared equals U squared plus 2AS. Notice that in each equation one of the quantities is missing. So the first one has no S in it, the second one no U, and so on. So you'll notice that the purple writing spells out suvat, and that's one way of remembering those should you need to. This is a prerequisites video, so the idea is that when these pop up during our work, you will at least know what they are. Notice that these equations are for acceleration in a straight line. During Unit 3, you will look at acceleration when it's not in a straight line, but you don't need to worry about that for now. So, moving on, Newton's first law. Now, you'll have come across this in Physics GCSE or Science GCSE, and Newton's first law is about balanced forces. So it says that a body will continue in its state of rest or uniform motion in a straight line unless a net or resultant force acts upon it. And basically what it means is that if the forces on an object are balanced, then in total, or the resultant of those forces, won't have any effect on the motion of that object. It could be still, it could be moving at a constant velocity, or in other words a steady speed in a straight line. It could be hovering or floating. And remember, Newton's laws are about force, and force is a vector. That means it has size and direction. Newton's second law is about unbalanced forces. So when the forces acting on an object do not balance, the resultant force will cause the object to accelerate in the direction of the resultant force. So that's an acknowledgement of the vector nature of forces. In other words, a resultant force on a body will cause it to change its velocity. So this means that unbalanced forces will cause acceleration or deceleration, which are in a sense the same thing, because deceleration is actually negative acceleration and vice versa. Don't worry about that too much. But it could at the same time or separately change direction. So we could have a change in the speed or a change in the direction, or both. Newton's third law is about action and reaction forces, and it states that whenever two objects interact, the forces they exert on each other are equal and opposite. So in this rather unpleasant example, if body A exerting a force on body B, B exerts an equal and opposite force on A. For example, if car A crashes into car B with a force of 10,000 Newton, then car B exerts a force of minus 10,000 Newtons back on car A. So the minus is telling us that it's opposite. We also will be looking at energy. So firstly, work done, and work done is force times distance. We'll come back to why that force is in red in a moment. So W is F times D, or just FD. W is measured in joules, the unit for energy. F is measured in newtons, the unit for force, and D is measured in meters. So the reason that force was in red is that work done is force in the direction of the motion times distance, and this will be important in this unit. And where force was a vector, remember that energy is a scalar. It has size but no direction. So moving on to gravitational potential energy. Gravitational potential energy is mass times g, the gravitational constant, times h, the height. So it's equal to mgh. And the energy is in joules, the mass is in kilograms. G, gravitational field strength, is in newtons per kilogram, or it's meters per second squared. And height is the change in meters. Kinetic energy, or motion energy, is equal to half times the mass times the velocity squared, or half mv squared. Okay, E is the kinetic energy in joules, mass in kilograms, V, the velocity or speed, is in meters per second. And that's the end of these prerequisites. So you can go on to the first Unit 3 video now.